Mhm.
So yeah, thank you everyone for joining us. We are today with Rand Hindi, Zama CEO, Dartmouth Blockchain and Blockchain at San Diego. BAF is a 501c3 nonprofit that aims to accelerate blockchain education and awareness. We are trying to host networking and educational meetups and support clubs worldwide so they can kind of spread the word about blockchain to students and help teach students about blockchain. So we are also supported by full disclosure by Nir and Algorand that help us keep running. And if you want to check our opportunities and other events like this one, you can check our website at blockchainacceleration.org to become a member. So Kunal, I'll let you maybe take it away, introduce yourself on the talk.
Yeah, sure. I'm Kunal. I'm head of education at Blockchain at San Diego. We started back 2 years back, and our club does like education and projects to get students up to date with what's happening in the industry.
Happy to introduce myself next. My name is Sunit. I'm currently a student at Dartmouth studying computer science and economics. The head of community at Dartmouth Blockchain, and we're really excited to be here. Rand, if you don't mind giving an introduction, a bio, kind of what inspired you to found Zama and, the company's mission and just sort of your philosophies as well. Would love to hear and start to kick off with that.
Sure. So my name is Rand. I'm the CEO here at Zama. My background is actually machine learning. I started coding when I was 10 and did a PhD in AI in 2007, so way before it was actually a cool thing to work on. And after that, I was running a machine learning company with a focus on privacy. That company got acquired, and now I'm basically running Zama, working on homomorphic encryption. I'm also doing quite a bit of angel investing. So my sweet spot is investing in very deep tech and blockchain companies before any other investors can even understand what these companies are building. I can give you a very quick introduction about Zama specifically. What we work on at Zama is a technology called homomorphic encryption. The idea of homomorphic encryption is that you can basically process data blindly without actually decrypting it. So imagine I'm a user and I want to access some service in the cloud where I'm going to have to send some sensitive data. So for example, imagine you want to chat with ChatGPT. What you would do is you would encrypt your queries, send an encrypted query to the server who's doing the processing. So the server doesn't have the data, it only has an encrypted version of it. But it could still run processing on it. It can still run machine learning algorithms. It can still do all kinds of different stuff on the data itself. Produce a result which itself is encrypted that you get back and you decrypt to get the actual response. So from your perspective as a user, nothing changes. You're sending some data, getting a response, but now the data is encrypted when you're sending it and when it's being processed, meaning it's encrypted end to end. And so this is really important because it no longer matters who's offering the service in terms of data privacy, because they're never going to have the data. They can get subpoenaed by a government. They're not going to be able to reveal anything. They can get hacked. They're not going to be able to reveal anything. A rogue employee could go crazy. They're not going to be able to learn anything about the users. And so this technology, is a pretty broadly applicable technology and something that's actually quite groundbreaking when you think about it. But it hasn't been used so far, very simply because, it didn't work until literally now, until Zama pretty much. Nobody could actually make this technology work, even less so make it easy enough for developers to integrate.
Yeah, no, definitely. And that's like super, we really appreciate the background and definitely super exciting stuff there. Kind of having some context on it as well. You mentioned that you're, and sort of put out your angel investing is across crypto, psychedelics, AI, even semiconductors and biology and sort of frontier health. You recently published a piece on like your 2023 deep tech and crypto theses. And kind of in that, you dive into your theses for next generation computing and for hardwares, as well as frontier techs in terms of diagnostics, psychedelics, etc. And your crypto theses, which you kind of describe this sort of cycle from the build phase to the bubble phase to the crash and the sort of cyclical nature of it. We'd love to hear kind of if you could relate some of these theses into where we are now, whether it's for crypto specifically or general, and try to understand, if you could present to the audience why you believe that's the way it is, and sort of help us guide discussion from there.
Sure. I think, crypto is a very broad thesis, and I don't know everything about crypto. It's too difficult to know everything about crypto now. It's a very big space, but I'm specifically interested in a few areas of crypto. I've been in that space since 2013, so that's why I've been already. This is, I think, my third cycle. So at some point you're like, yeah, whatever. Okay, so it went up and it crashed. You kind of just learn to not care anymore about the short-term sort of ups and downs, and care more about what's going to come next. And so I think when I look at what's been important in 2013, what's been important in 2017, what's been important in 2020, each time we're getting closer and closer to something that resembles a mass market consumer use case. It started with payment, of course, with Bitcoin. And then after that, it was the whole craze about ICOs and all kinds of different projects. Then there was DeFi, NFTs. And I think some of the things that are going to be driving the next cycle are going to be gaming, for sure. I think gaming is overdue as a major attractor of people into crypto. I believe also identity is going to be a big deal, because at the end of the day, when you think about what your wallet is, it is a way to authenticate yourself with a private key. And so if people are going to have to sign every piece of content online to prove it's real, I think that's a very good segue into using crypto as well. So I think identity is going to be a very big deal for crypto. And I think in general, privacy is also going to be a major driver. The reason for this is that when you think about an ideal computing platform, what you want is functionality. So typically being able to develop all kinds of applications. So that was solved with Ethereum and smart contracts. The second thing you want is scalability. You want to be able to address a large number of users concurrently. This was basically solved with rollups. And what you finally need is confidentiality and privacy. Because if everything you do is public, there are many use cases you cannot build or don't want to actually interact with. And so this is going to be the last mile for crypto. Because if you have something that's programmable, scalable, and private, you can pretty much build anything. You can build not just things that people can see and that can be public. You can also start building games, for example, where you have to keep some stuff secret. Today, for example, if you wanted to play poker on chain, you wouldn't be able to because your cards would be visible. It wouldn't be a very fun game, obviously. So you need a layer of privacy even for very simple things like that.
Right, that makes a lot of sense. And obviously, kind of one of the key primitives of homomorphic encryption right now is the idea to process sensitive data and essentially perform encryption without necessarily requiring decryption first. I'm wondering if there's any other, as you're sort of at the pushing edge of the technology, and particularly with your open source emphasis, if there's any other primitives you think are being unlocked or like soon to be unlocked that'll sort of add and make this more robust, and more so, which of the sort of verticals, whether it's data analysis or cloud computing, or just even secure communications, financial services, things you talked about, are you most excited for, and what do you kind of see is on the horizon as well? That's also intriguing.
Right. The reason why homomorphic encryption wasn't used before is because of three things. First, it was too slow to be useful. It would take like 1 million more compute to actually do something simple. The second problem was you could only do additions and multiplications. So anything more complicated than that, you needed to approximate using some kind of approximation function. Well, that's fine for things like machine learning, which inherently is statistical by nature. If you're thinking about a smart contract, it wouldn't work because in a smart contract, you cannot approximate the conditions. If I'm going to be sending you $1 million, either I have it or I don't have it. If I approximately have $1 million, it's not really going to work, right? So you need to solve the problem of expressiveness of homomorphic encryption. And the third problem was very simply usability. Unless you had a PhD in cryptography, it was impossible to use homomorphic encryption correctly. So these are exactly the things that we're solving at Zama. We built a set of frameworks that makes it very easy for developers to use homomorphic encryption, even though they know nothing about cryptography. So for example, for machine learning, we created a way where you can take an existing Python code that you built using PyTorch, scikit-learn, whatever, and we can automatically convert it into a homomorphic equivalent that can basically run on encrypted data. So without changing anything to the way data scientists are working, we can turn an existing AI model into a homomorphic equivalent. And we've done something similar for blockchain as well, where we've basically extended the EVM to support homomorphic encryption directly in Solidity, so that as a developer, you don't have to learn anything new to start building smart contracts, which are confidential.
Let's see. I had a question about your last point. I was wondering if too much abstraction creates some kind of like security risk for like application developers. You know how like Solidity devs, if you don't know how like self-destruct works, you could have some unforeseen issues. Do you see the same kind of issues with like the libraries you were talking about, like TFHE or Concrete?
Right. Quite the opposite, actually, in this case, because when you look at cryptography, the biggest issue is finding the right parameters. If you choose the wrong parameters, best case scenario, things are running more slowly than they should. Worst case scenario, you don't have the security level that you want and your system is basically broken. So you definitely don't want developers to start playing around with cryptographic parameters that they don't understand. So for that, you want to automate that process, which is exactly what the library does for you. It effectively finds the optimal parameter set that guarantees maximal security and best performance for a given program you're trying to run homomorphically. So I think, I agree with you with Solidity. You need to understand what you're doing, but it's also because Solidity was designed in a way that, well, how to explain? I don't think that a modern language would be designed like that by someone who would think about safety first. But it is what we have right now, and so we have to basically do what you have to do to make it work. But the nice thing about homomorphic encryption is we get to think about those things up front, and so we don't have to wait for people to discover by themselves that this is going to be a problem, because we know this is going to be a problem, and so we might as well just fix it in the library itself.
Okay, that makes sense. So you're trying to build like something like TensorFlow rather than Solidity.
Yeah, correct. Exactly. So effectively, like, we have a set of primitives which are plugged into a compiler, which takes some high-level language and takes care of everything else from there.
I see. And you were talking about the EVM rollup too, right? I was looking at the docs, and you could do like I think private transfers on them. Like, what other applications would you like to see on that?
The reason why we started working on confidential smart contracts is because we saw a lot of use cases in blockchain where people needed to hide things on chain. So I gave an example of games, poker, for example. If you and I are going to be playing poker on chain, the cards have to be hidden until we reveal them at the end. Otherwise, it's not going to work. And sure, you could always design like a zero knowledge system to play poker on the blockchain. But what you're really doing when you're using ZK is you're doing the computation off chain. You're keeping the data off chain and then sending a proof on chain itself. With a homomorphic encryption, everything stays on chain. The data is on chain, the compute is on chain, there is nothing happening off chain. And so it makes it much easier for a developer to understand and follow what's going on, because they can, basically keep track of everything. So games is a very important one, I think. Another thing which is actually quite nice related to that is if you can compute things encrypted on chain, you can generate random numbers on chain privately. Why is that important? Because it means you no longer need an external oracle to generate randomness for things like casino games or for things like, any kind of use case where you need a random number effectively. Identity is a very big deal. You can basically keep your identity on-chain encrypted and do homomorphic KYC for DeFi, for example. So you no longer need to put that off-chain. You can keep everything on-chain and do, KYC DeFi for compliance. Another cool use case is blind auctions for NFTs. So in general, if you're going to be bidding on an NFT and you don't want someone to know how much you've been bidding, you could do an encrypted bid on your NFT. So that's quite useful for many, many cases. You can have DEXs where the order book is private, so people cannot actually front run you with MEV because they actually don't know what you're trading. I mean, effectively, everything you wouldn't do in the cloud if it wasn't private, you're not doing on a blockchain right now. So I would argue that what we're doing on a blockchain right now is a very, 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 very small percentage of what we could do if things were not completely public.
I see. Also, do you see like applications which use both zero knowledge and FHE in the future?
Everything will use zero knowledge for scalability.
Mm-hmm.
And I think that this is the important part. ZK, in the context of blockchain specifically, isn't a privacy technology. It's a scalability technology. What you want is FHE for privacy and ZK for scalability. So effectively, what you really want are homomorphic ZK rollups. And effectively, if you can do that, then game over. You can basically do whatever you want on blockchains.
I see. And ZK has had like a lot of hardware requirements and advancements in the last year or so. Do you think the same thing will happen with FHE too?
Absolutely. Right now at Zama, we're seeing a 4x improvement in performance every couple of years or so. So we basically have like a 20x improvement on our technology since we started a company. And what we're expecting is to get another 1000x to 10,000x improvement in 2 to 4 years, thanks to hardware acceleration. So for blockchain, fortunately, we can already start pushing stuff without hard acceleration because a smart contract is a simple application that's already slow and expensive. So if you ask me, it's a perfect use case for FHE right now. But if you want to start scaling homomorphic encryption to things like machine learning, you need hard acceleration. So we've estimated, for example, that if you want to run something like GPT homomorphically, it would probably require something like a 50,000x speed up versus what we have now, which is attainable in 5 years with the current pace of acceleration with hardware. So 5 years from now, you can run GPT on encrypted data. So blockchain by then will be, piece of cake.
Okay, yeah. Also, I think in the rollup, you use like threshold FHE, right? Can you like differentiate between the two and why we need threshold for?
Right.
Yeah.
So when you want to build homomorphic encryption into a blockchain, there are multiple problems you have to overcome. The actual homomorphic computation part is the easiest part, interestingly, for that protocol. So the first thing you have to keep in mind is if multiple users are interacting together, what that means is that you need to share the same key on which to do the computation. Because if every user is encrypting their data under a different key, they're not going to be compatible, right? So you need basically one single key for the whole network. The problem is if there is one key for the network that everybody's encrypting under, who has a private key to decrypt everything? You cannot obviously have one validator on that key because otherwise it would be a very centralized system. So instead, what you do is you split that private key into a number of small pieces and you distribute that amongst all of the validators. And in order to decrypt anything, the validators need to agree with at least a 2/3 threshold, hence why it's called threshold, to do the decryption. So as long as at least 2/3 of your validators are not colluding, it's impossible for anyone to decrypt anything from the blockchain. And so how do the validators know what to decrypt? It's very simple. They just look at a smart contract. So when you're a developer and you're building a smart contract that includes encrypted values, you also have to define how and who is allowed to see the encrypted value. So you basically have all the logic for access control and visibility of the encrypted state in the smart contract itself. And so the validators just basically run that, and then they agree, okay, well, we all agree that this is what should be decrypted. There you go, you get the result.
Oh, I see.
So you see, it's a
Mhm.
combination of FHE for the private computation and threshold cryptography for the decryption that makes this protocol work.
Okay. Also, so you are implying like, say, if you're doing like ERC20 transfers, your balances are also private.
For example, but not just the balance. You want the balance to be private. You want the amount being transferred to be private. Potentially, you want the address of the person receiving the funds to be private. But it's even more complicated than that. You also need the supply to be what's called differentially private. Why? Because if the supply is public, the token supply is public, every time someone's going to be minting tokens privately, you can just look at how many tokens in the supply were added, and you know how many tokens that person just minted. So you need to avoid, this kind of differential analysis that would enable you to infer the private balances. And so for that, what you basically do, and this is why everything kind of like falls in together, right? What you need to do is you need to generate an encrypted random value that you're adding to the supply whenever someone is minting, so that the supply is approximately the correct supply, but not exactly. So you wouldn't be able to know how many tokens were just minted for a specific user. You would only be able to know that the supply is like plus or minus 5% of the correct value. So you see, like you have to think about all of those things, because otherwise you end up with a system that looks private but is easily breakable from a privacy perspective.
Yeah, I mean, even in like AMMs, right? Because if you had like amount in and amount, even if you had amount in or something private, because of like the curvature of the like the AMM curve, you would be able to figure out, right? That would be pretty trivial.
Exactly. So I think that's going to be an interesting, topic, by the way, is like, what is the right level of like fuzziness that you need to add to the curve in order to hide how much is going in and out of the pool, right? I agree. I mean, these are like super interesting topics, and to be honest, I don't think anybody has figured this out yet, because well, nobody had to figure this out yet. We're inventing something new here, so I think it's going to be a very, very interesting area to do research on, for sure.
I see. Yeah, talking about like adding random fuzziness, like noise management has been a big issue in FHE, right? How are you guys solving it?
We don't have that problem. So the technology we use, which is called TFHE, so there are basically three main families of FHE technologies. There is a technology called TFHE, which is what we basically do at Zama. There is a technology called CKKS, and then there is a technology called BGV. BGV is the same thing. CKKS and BGV can only do additions and multiplications, and they can only do a certain number of them because noise accumulates. After that point, you have to do a very expensive operation called bootstrapping, which in the case of CKKS and BGV takes 20 to 30 seconds. So, not very useful. In the case of TFHE, you can bootstrap very quickly in a few milliseconds. And so you basically do that all the time. So there is never any issues around noise, because you always keep the noise in check with this very fast bootstrapping technique. So TFHE has this particularity that it has, I would say, unlimited noise budget, in the sense that it always bootstraps very efficiently. The second thing, which is really nice about TFHE, and the reason why we built this technology, is you're not limited to additions and multiplications. We can also evaluate a homomorphic table lookup. Why is that important? It's important because any function can be represented, any integer function can be represented exactly as a lookup table. And so if you can homomorphically evaluate the table lookup, it means you can homomorphically evaluate any arbitrary function on your encrypted data without approximation. And that's how we're able to do things like comparisons. That's how we're able to do things like nonlinear activation functions in your neural network. And that's how we can guarantee that your encrypted smart contract will have exactly the same behavior as if the data was not encrypted.
Oh, I see. Yeah, that makes sense. I'll give it back to Sunit to ask questions.
Yeah, thanks, Kunal. So I have to jump in here, kind of shifting gears a little bit. One of the things we're curious about is sort of why your decision to go open source. We're seeing this definite, sort of larger push in the community, and a lot of corporations and sort of initiatives trying to build open source software, cryptographic tools, etc. And even from the sort of let's say more like traditional technology side, I believe Microsoft has launched some open source FHE libraries. I think Seal and HEWN, and then IBM has also done. And conversely, there's like, for example, companies and protocols involved in crypto, like the Mina protocol, that's more zero knowledge computation focused, but it's providing modularity and tools for developers to sort of do, FHE and things like that. So wondering sort of why the decision to go open source, and what do you think of the landscape right now between like open source, between protected, and how that's kind of affecting just what we're seeing right now, we sort of expect to see as well.
I mean, I would ask you, why not open source it? I think, a lot of people think that open source means free, means you cannot build a business. That's completely wrong. There are many ways to monetize open source projects. The one we use at Zama, for example, is called dual licensing. So everything we open source is open source under a BSD license, which means it's fully permissive. However, the BSD license doesn't say anything about patents specifically, which means that it's really kind of up to you to figure out, how to get the license for those patents. And in the case of a commercial product, that's what you really should be doing. And so that's effectively what we sell. So everything we do is open source. It's completely free for research. It's completely free for personal use. It's completely free for prototyping, for everything. But if you are going to be making money with our technology, we should be making money. That's the deal, effectively.
Right, that makes sense. So in sort of your eyes, it's a way to help with, growth and bringing in developers and encouraging people to build on top of it and find novel applications,
right? Yes,
but also protect them like a monetary standpoint.
It's great to build a bottom-up adoption strategy, and it's also great for auditability. I don't think you should ever trust a crypto system that isn't open source and that isn't audited. If the code and the logic was hidden, how would you be able to trust that it has been implemented correctly, that the math actually work and isn't insecure? It would be impossible, right? So cryptography has to be open source. It has to be open source. There is no choice around that. If anybody says otherwise, if anybody pretends that you can get security by obscurity, they're very strongly mistaken, and they probably don't understand anything about cybersecurity.
Certainly. And so, going back to your earlier question where you asked, why not open source? I'd say the sort of devil's advocate perspective to that is that there's a misalignment of incentives, right? Whether it's from like a general corporations wanting to make profit, or more, specifically, I would say protect their moat, kind of give them the most runway as possible compared to competitors or their libraries, whether it's to protect from regulation, sort of provide this safeguard. But similarly, we've seen different decisions from traditional technology, for example, like Twitter publishing its algorithm, making that open source and things like that. So do you think there's like this shift is, and like I mentioned before, Microsoft and IBM and others are making some open source libraries. Do you think we're going to see a meaningful shift towards open source? And like to your point, in this space specifically, where it is cybersecurity, encryption, and data, and the themes are very aligned? Or do you think it's just something in the short term that mostly we'll see what's traditionally seen in the past, where software is locked in and sort of gated, with only a handful of companies or handful of players actually making a meaningful push towards open source?
I think we're definitely going more open, for sure. I think people are moving more towards open source as a viable model now. The only exception to that would be OpenAI, I suppose. But I mean, that's part of their marketing, to keep things private and, to basically say that if they opened it, it would unleash the end of the world and whatever. It's not how things work, right? I think unless you have a very strong marketing reason for keeping things private, or if you have a technology that cannot be patented, then yes, it would make sense to keep it private. If you have a technology that you can protect, or a technology that is useful for other people, that you want people to adopt massively, you have to go open source. I think, now that we have massive companies built on top of open source software, I don't see any reason why this would be going the other way around. Yeah, quite the opposite. I mean, I've been a big open source advocate forever. My previous company, everything we did was open source as well. We had like 40,000 developers using our stuff. I just don't think of any other way of doing things, to be honest.
Certainly, that makes a lot of sense. And you touched upon how some of the problems like FHE faces, for example, like noise growth and things like that, you guys at Zama aren't facing. In terms of the other, let's say, general like problems that a lot of tools run into, whether it's like circuit complexity, sort of lack of standardization, where it's difficult to sort of evaluate different FHE applications from one to another, even just availability of sort of hardware for the common user. Where do you think the bottlenecks and the biggest challenges you face like actively today are? Is it on the development and hardware side? Is it just like educating potential users to drive adoption? Is it more finding like applications, and like is this like legislative sort of like overhaul you sort of see? Would love to kind of hear where the active bottlenecks are and the challenges you face and how you're going about navigating them.
The main challenge so far was a technical challenge. We had to make it work. That's done pretty much. So I think that's no longer a challenge. The challenge we're facing now is actually education and adoption, just getting people to know that this works. Most people think FHE is like 10 years in the future. Some of them think it might never work even. And I understand why you would think that. If you're outside of the field, you probably only see what's visible, but you don't see what's coming next. Kind of like in AI. If you're outside of AI, you would think that it just didn't work, and then all of a sudden, OpenAI releases something that everybody's like, "Oh my God, it's a revolution." Yeah, it's amazing, but if you were working in AI, you knew that this was coming. So same thing here with FHE. Standardization is important. It's happening. There is a standard being drafted at ISO right now. I think that's definitely going to be needed for more enterprise adoption of FHE. For blockchain, nobody cares, to be honest. Blockchain is an early adopter of cryptography, and nobody's been waiting for ZK to be standardized before they started actually using it. And I think this would be the same for FHE. I'm very, very strongly convinced that blockchain is going to be an early adopter of homomorphic encryption, and that the broader enterprise cloud sort of space will take over from 2025 once accelerators become available and once things are a little bit more standardized.
Right. That makes a lot of sense. And so you kind of point to this, blockchain just being one of the early adopters, and there's other industries that may step in, and crypto being one of the reasons because of its sort of foundation with cybersecurity and how there's like alignment of incentives. You've discussed use cases in terms of like things like facial recognition, healthcare, financial services, but what other sort of domains, whether in technology or otherwise, do you think are going to be along this early adopter wave? Or is there like some domains where you think, hey, if we reach adoption here, I was to see X use case or X example of it being widely used, and that means we reach some sort of critical mass where FHE is now like the new standard. One of the things you've talked or seen is a sort of give like HTTPZ, right? Where you'll be able to sort of have just standard, just like going from HTTP to TS with TLS encryption, and now encryption to the whole way process. So do you think that's, for example, one of those critical mass points, or I'd love to hear kind of in your mind how you envision that?
I mean, my bet, and again, I'm biased, but my bet is that blockchain is going to put FHE on the map. Machine learning AI is going to make it ubiquitous. Because when you think about the issues, as you said, blockchain, we need it. There is no good solution for having privacy in smart contracts. This is a great solution. It works. We're going to use it. I can guarantee that everybody's going to use that in the next few years. On the AI side, the issue is that companies are still telling you, oh, you can trust me. I'll keep your data private. You cannot make that claim on blockchain, obviously, because nobody is actually keeping your data private because everything is running publicly. But in the case of using OpenAI or Microsoft's Bing or something like that, you kind of have like, hey, whatever, they have so much data, why would they leak my additional information? I think that's going to change. I've been a big proponent of privacy in AI for years. I think that the tide is shifting, especially now that we are using those things for more and more things in our daily lives. So I think that's going to be a major driver. If everybody's going to be using those new modern, AI models, then everybody is going to be using FHE to secure the data that's being sent to those models. But as a user, to be clear, as a user, you're never going to notice. For you as an end user, it's going to be transparent, right? This is going to be like built into the protocols. This is going to be built into the communication layer. It's never going to be something that's actively managed by users. And this is why, one thing I've been telling people is that my goal is that nobody cares about privacy, not because it's not important, but because developers will have solved it for everybody else.
I see. Yeah, regarding the, like recently there has been like push against like Mid-Journey and all of how realistic these models have become, so that we aren't able to figure out if it's real or not. And people have been talking about like tested sensors. But say you wanted to do some authenticated computation on like a actual picture. Can we use FHE for that?
I think you can use cryptography for that, and you should do
Mhm.
that. So it's funny. This is actually something I wrote about as well in my blog recently. I've been telling people since 2015 that the biggest risk of AI is actually deepfakes. So no longer being
Mhm.
able to know what's real from what's wrong. Because if you lose trust in everything around you, you go crazy, man. Like imagine
Mhm.
if every person you talk to, everything you read, everything you see is potentially fake and created to manipulate and scam you. I mean, dude, you're going to go paranoid. You're going to go nuts. So it's obvious we need a way to solve that problem. And the only way I can think of solving the problem is to have users and people authenticate every piece of content that they publish using a cryptographic key. So the same way that you can sign your Ethereum transaction to prove that it's you, you will sign every Twitter post. You'll sign every upload to YouTube. You'll sign every picture on Instagram. And sure, you could still make up those pictures, but at least people will know and attribute it to you. So it's going to be much, much, much harder to just diffuse fake news without being able to retrieve the original source. And I think that's a very important thing. It creates accountability. I can guarantee that if every person who's posting fake news was traceable, like if you could trace back everyone, you'd have a lot less of it. So I think that plus regulation, to be honest, is probably going to prevent most of the big problems. We're just going to learn not to trust anything that hasn't been signed and that we cannot verify. That's it. Verify, don't trust, pretty much.
I see. And for like identity solutions, what do you think about like solutions like WorldCoin? Do you think that's feasible?
Yeah, why not? I don't know if this is a right solution, but it's definitely feasible.
Mhm.
There's a new standard that was recently enacted at the W3C called DID, decentralized
Mhm.
identifiers. So now we have a standard. Most crypto wallets are implementing it. Most non-crypto wallets are implementing it. Very, very soon, you're going to basically have an identity wallet in every one of your devices, and then you're just going to sign using whatever identity you want. Your identity could be your government identity. It could be your Facebook identity. It could be your Twitter identity. It could be a self-signed identity. The level of trust in each of those identities, of course, will be different. I think people will trust your government identity more than they will trust some anonymous Twitter account that you've used to sign some content. But nonetheless, you will have active identity management in everything you're doing.
I see. Do you have any questions, Sim?
Yeah, kind of wanted to shift over to this big picture idea. So you briefly mentioned like the importance of regulation, and obviously with things like the Restrict Act, for example, and similar, but relevant domains, that's come into a lot of controversy recently. Like, I think it's unlikely necessarily we see like legislation specifically for FHE, but we see a lot of legislation surrounding cybersecurity protection, where there's just like overreach and where to draw some of these lines in the sand that regulators are kind of actively dealing with. So, do you have a specific take on where you think regulation is beneficial and where it's not? Do you have a perspective of what you think either legislative or just like non-legislative, but like advisory committees to sort of hold or consider? And really, how do you see like things like adoption, development, or et cetera, being impacted by the regulatory landscape?
I mean, I'm European, so I'm obviously very comfortable with regulation. We have to. We kind of had a history of that,
Sure,
right?
sure.
I was actually part of something called the National Digital Council a few years ago in France. So we were an independent council that was advising the government on their digital strategies. And I was specifically responsible for everything related to AI and to privacy. So this was before GDPR. This was before any of those things. I've been pushing for more regulation for privacy, because I think that's the only way that companies will learn. Unless you actually force companies to do things the right way, they have very little incentive to do it, to be honest. So I think that's why, in that case, a good thing. Probably it's going to be the same with AI. There is a AI regulation in Europe, which is unfortunately very poorly written, but hopefully they're going to be amending that soon and making it a little bit better. The problem with regulation is when it's written by people who do not understand the technology they're trying to regulate. And it's very difficult with the current pace of progress to have foresight on how a technology will impact things. You have to be a lot more reactive, which means you need people who can quickly figure out what's happening and react appropriately. So in Europe, at least, the way the regulation was written was a little bit vague on purpose, so that there was room for interpretation on a case-per-case basis. So it basically gives you guidelines more than it gives you strict rules at this point. And it's never been an issue. I've never heard of any company that wasn't able to build their business because of regulation in Europe. I think that's a discourse that a lot of American VCs want to have towards European companies, but it's honestly unfounded. I've never seen any company shut down or be prevented from building something just because of regulation. On the contrary, it gives them something safer to play with. Think about the crypto stuff in the US. Nobody knows what the SEC is going to do. Therefore, everybody's shit scared of building a crypto company in the US. What happens? Everybody's building it outside right now. This is what happens when you don't have regulation. People have no idea what they should do, and therefore they get scared of doing something that eventually will be considered wrong. At least in Europe, you know what you have to do and you know what you cannot do.
Right. That makes a lot of sense. And I appreciate you explaining your perspective of generally being like, definitely open to and also contributing to actively through the council, like you mentioned, sort of legislation and regulation, kind of advising on that. And going off your point of, there should be some, like, let's say, guardrails and some general guidelines, but it shouldn't be necessarily restrictive to build. And the cases of you observed, it hasn't been that, where there's actually been like a slowdown in building as a result of it. Well, what do you sort of, think about, like, the, let's say, approach, like some of the conflicting approaches, I should say, we see in government? You mentioned the SEC. Gary Gensler seems very actively, especially in this recent short term, taking another additional push against crypto, and we're seeing a lot, come out there, both for the general banking system and specific to emerging financial technologies. But on the other hand, you see this internal conflict, right? Like SEC Commissioner Hester Pierce has kind of proposed this like safe harbor 2.0. With the sort of approach SEC and other regulatory agencies have taken in the past, being, let's give like a regulatory moat, usually about 3 years or so, where in emerging technologies you can build with sort of limited regulations and, like you said, guidelines but not stringent rules to help work around and come to sort of an effective tool that complies with legislation. And the Safe Harbor 2.0 is kind of just her sort of example for that, and her proposed policy for that for the crypto space. So is that kind of what you see, like aligning? Is that something, like, do you have any thoughts on that specifically? And I mentioned European, would love to hear any examples of sort of the active debates and things happening on that side of the pond as well, and kind of any ideas you have on that.
Oh, in Europe, it's very simple. We have a new regulation called MiCA, which is very simple, that basically outlines how to build any kind of like digital, stuff, blockchain companies, cryptocurrencies, tokens, NFTs, exchanges. If you comply with that, you're good. Very easy. We have a framework. We have something that people can just follow. If you follow, you're good. That's it. So I think, Europe is actually going to win a lot of the crypto companies now because of this clarity in the regulation landscape. So, maybe the US citizens will not have access to all of those DeFi protocols, but, like it's 300 million people out of like 8 billion. 300 is very rich million people, right? So definitely not a market you want to ignore. But if that market doesn't exist, there's plenty other opportunities in the world that isn't US centric in crypto. And in fact, actually, I would argue that most of the crypto companies are not even in the US already. So like, I think aside from preventing just regular people from using crypto, it's probably not going to prevent the ecosystem from growing anyway.
Right. That makes a lot of sense. And kind of to your point on that, one of the things you mentioned in terms of philosophies in the past before is the idea of like I think we were having an interview where they were talking about like, whatever sort of experiences and insights you've gained being like a multi-time founder and someone who's been in the space for a long time. And one of the most important things you seem to highlight was like, you discovered this playbook. Once you build, 3 or 4 successful companies, you understand how to sort of iterate and sort of like recursion process in terms of scalability and building. But you also said, it's important to meaningfully commit, 5, 7, 10 years on the problem and like recognize you're willing to do that. So obviously, you have done this in the past multiple times. You built a lot of successful companies and helped with a lot of initiatives, advised to many as well. Why is like, and you mentioned your background being in the sort of computer science, AI, FHE side, but why is this the problem you are sort of focused on actively and expect your future to be focused on? And what, in terms of your past experiences, this playbook you mentioned, do you think is like really relevant today? And could you share for perhaps a lot of the listeners on the call who might be at that college or younger age trying to also build, but don't necessarily have that experience with them under their belt?
So I got interested in privacy a long time ago. When I was a teenager in the 90s, I started a social network back in 1999. It got quite popular in France, to be honest. And so, at the time, nobody was really talking about data privacy. It wasn't really a thing yet. But I had one story specifically that opened my eye to that problem. I was in school, and there was like this older dude who was basically bullying me. He was bigger, stronger, older. Not much I could do fighting back physically. And at some point, I kind of like got fed up with it, and I was like, you know what? I'm gonna look if he's a user of my social network, and if he is, I'm gonna look up his private messages because we had like a messaging thing integrated. I'm gonna look up his messages and see if there is anything kind of embarrassing that I could find about him. So he was using my social network, and I did find embarrassing stuff, and I did confront him with that, and he did leave me alone. And so, I started thinking, well, he was bullying me, so I bullied him back, in a way. So it's kind of like fair game. And we can debate the ethics of that, by the way, for a very long time. But it did work. It did, change my relationship to high school at the time. But it also made me realize that it was wrong. Just because the guy was a bully, it didn't give me the right to his privacy. And I couldn't just shake that feeling that like, I don't know, like I shouldn't be able to do that. I really shouldn't be able to do that. And it kind of like stuck on the back of my mind. And when I did my PhD was in machine learning applied to biology. And so I was manipulating a lot of like genetic data, a lot of like very kind of like health related data. And that point I was like, okay, if machine learning is going to be requiring a ton of data, and even a simple social network is already a privacy issue, then obviously we have to figure this problem out in the future. And so that's why, I decided that privacy was going to be an integral part of everything I would do going forward.
Certainly. Yeah, I really appreciate that sort of both that example, but I think it gives you like a real, personal like understanding of like how and why security is important, and more so the sort of like flip side of the coin. So that actually is, I think, a really powerful example. It speaks to the mentality a little bit. So I appreciate that. Kunal, if you kind of want to take it over from here, ask any questions you have and sort of wrap us off.
Yeah, I guess that story also kind of reminded me of what like Snowden was saying when he was at NSA and he saw like people misusing it to spy on partners and like people they were close to. So yeah, I guess I had one final question, which is like, if you were to like suggest to like a student who is like has some basic understanding of cryptography right now, and because you said you wanted to be like very abstracted away, what kind of projects would you suggest them to build in like a short enough time frame for them to like sort of learn about FHE but also build something interesting?
So I think what you should do if you're a cryptography student is you should look up our bounty program. So we started this bounty program at Zama where we're giving between $500,000 and $1 million in prizes to people solving all kinds of different problems. So these could be things like building an application using FHE, or it could be improving the cryptography, improving the implementation. There is like everything from math to engineering to application level stuff. I think that's a good way to get into it because depending on which bounty you're trying to solve, you'll get more or less deep into how FHE actually works. And we find actually interestingly that even though we have, I would say, professional bounty hunters, we're trying to solve some of these bounties, a lot of the people who are trying them are actually trying them to learn FHE specifically. It's just a fun way. It's like, it's a fun way of doing it. So for example, there is one right now, which is about doing a regex engine in FHE. It's a fun project. It's not a very complicated one, but it forces you to think about, how to represent things in the encrypted space, how to use all those tools. And you could use our high-level tools and just write a Python code that automatically let everything else be converted. Or you could use our low-level FHE library and do everything from scratch yourself. Both solutions would be acceptable in this case.
I see. Yeah, I guess that's all of my questions. If Sunit doesn't have any more questions, we can wrap it up here.
Yeah.
We can open it to audience questions, right? Yeah.
Yeah. If anyone has a question, feel free to raise your hands and we'll add you.
What's up, guys? So I had one question on, so say somebody has a concept mapped out, but they don't have technical skills to develop any of it. What would your advice be? What channels to pursue in order to find other developers that are like-minded that would love to, I guess, take on the endeavor?
I think that's a very general question. To be honest, I'm not exactly sure how to answer that. I would say the best way is to hang out in communities which are already interested in what you're trying to build. There are usually people trying to find a project to work on. So for example, if you're trying to do something in a homomorphic encryption and you want to find, someone to work with you on it, you could go to FHE.org. It's an open community. There is a Discord server. There's a lot of people hanging out there talking about all kinds of different things. That could be a starting point. And I'm sure you have the same kind of communities that exist for pretty much everything.
Sorry, I was typing something out, but I just left a comment. Appreciate it. Just kind of very 30,000 foot overview of the endeavor. But it would basically combine homomorphic encryption into an application that basically allows people to own their data privately and securely, and then be able to leverage that data with edge AI that they would actually be able to own, rather than AI not being owned by individuals.
Yeah, you should definitely talk about that with people in the community. I think I would be surprised if nobody's already thinking about something similar.
Okay, awesome. Yeah, appreciate it.
Pleasure.
All right. If there's no more questions, we can wrap it up here. Yeah. Thank you, Rand, for coming, and this was super insightful.
Pleasure, guys. Thank you for having me here. And if anybody wants to talk, my DMs are open.
Perfect. Thank you, Rand. Appreciate the time once again. And thank you everyone for tuning in and joining us, and hope this is informational and a rewarding session for everyone.
Sounds great. Have a great evening, everyone.
Appreciate you guys.
Thank you so much for coming. See you. Bye.
Bye. Thanks.